Okay, so I know some of you were struggling today trying to graph your parabolas. So a quick way, here's a hint, to find a vertex is to use negative b over 2a, and that gives you your x value of the vertex, and then substitute that back in to get the y value. So I found the vertex for the first one, I should say the left side, is 2, -1. And then if you remember anything about parabolas, since my a value is 1, then I'm going over 1, up 1, and over 2, up 4, because that's the form for y equals x squared. And if you go off to the side and graph y equals x squared, and you check to see how much do I move from the vertex, I would go over 1, up 1, and then over 2, up 4. And so that gives me all the orange dots. Excuse me. And then I went back, and the vertex for the second one, again using negative b over 2a, gives me 1 for the x value, and when I plug the 1 back in, I get 4 for the y value. And since this a value is -1, the only difference is that I'm going down instead of up. So over 1, down 1, and over 2, down 4. And so that's a quick way to graph them out. Then I figured out where they intersect, of course, by setting them equal to each other. And I get x equals 0, and of course I can plug that back into either equation to get the y value, and x equals 3, and again I can plug that into either equation and get the y value. And of course I can also note, since those happen to be specific points on my graph, as I graphed it, I can actually pick them off of the graph in this special case. So now I'm looking at the area between my two curves from my examples. I've figured out that I can do the upper curve minus the lower curve. And in this case, the upper curve is the green one, and the lower curve is the orange one. And of course, since I'm trying to figure out area, I will integrate. And now when I look at what the bounds are, well, the leftmost bound of where they intersect is 0, and the rightmost bound of where they intersect is 3. And of course, those are the x values. So I'm integrating with respect to x. So now I'm showing where I've used the upper one, which we said was the green one, minus the lower one, which I graphed in orange. And so now I've substituted them in. So my green function was g of x, and my orange function was f of x. And just to make it a whole lot simpler, all I did here was combine like terms. So I put all the x squareds together, and I put all the x's together, and then of course the constants are going to cancel each other out. So it makes it a whole lot easier to do the integration. I know some of you are saying, Torres, you are a genius. And so then when I power back up, of course that first term will turn into a 3, and I'll have to divide by that new exponent. And the second one will turn into a 2, and I'll have to divide by that exponent. Of course that part's going to reduce. And I would like for you to pause the video and see if you can get the right numbers when you plug in your 3 and your 0. If I plug in 3 first, I'll have -2 times 27/3, which is -18, plus 6 times 9 divided by 2, which is 27. And that's all from plugging in just the 3. And then minus, and of course if I plug in 0, both values are going to be 0. And so I get a grand total of 9.